The next presenter is going to be Paweł. He's going to talk about all the effort that he's been doing around the CPU and GPU usage in WPE. He's been working for quite a while in all sorts of performance-related improvements, and it's kind of also the person that mostly working adding support for damaging, translating damaging information all the way to the composition, which has been quite important, and many other things. So if you can share, thank you. And just use this microphone, and off you go.
Okay, thank you. So hello, my name is Paweł Lampe, and yes, my talk will be techniques for reducing GPU usage in WPE. Although in reality, this talk is more about the CPU-GPU trade-off, actually. So quickly about me, I'm working for Igalia, and I'm a WPE WebKit developer since a few years. I'm specialized. I think this mic is broken for some reason. Woohoo.
Use this one. Sorry.
Okay, hope this one works. Yeah, so I have experience with graphics and multimedia, although I'm not working with multimedia anymore. And that's it. So I'm going to talk about the CPU and GPU, but first we need to understand in the web browsers in general, like what's the current situation. So as we know, over years, the web engines basically started using GPU more and more, and right now the situation is like on the slide. So the GPU is usually used for rendering, basically to offload as much as possible, but also for compositing, and the rest is like CPU stuff. So JavaScript execution, DOM processing, styling, layout, everything is on CPU. And the reason for that is that on desktop, on average, the GPU is very powerful. So normally we're talking about like 10 times more powerful. And if you think about GPU, it offers like extra processing power, but in general, it's great for like accelerating graphics processing, basically. And also, in case of desktop class devices, it's like GPU usually has a dedicated memory and a lot of bandwidth you can use. Not to mention that it accelerates many primitive operations, so the browser can basically utilize that. So this is great, and therefore that's the reason that the browsers are, trying to use and utilize GPU as much as possible. However, on embedded devices, the situation is like very much different. Of course, GPU means extra processing power. You can utilize that. It's still great for accelerating, rendering in general. But the thing is that on desktop, on embedded devices, GPUs usually have like limited memory. It's often shared with CPU, so it introduces some problems. Also, the acceleration is not as good as on desktop usually. So you may be missing some extensions of OpenGL or whatever. But the biggest problem is that on embedded devices, in general, the power of GPU is like very much different. Sometimes some platforms may have like very powerful GPUs. In some cases, it may be like not that powerful, but you may also have platforms without GPU at all, like just frame buffer, like very basic graphics. So you may have different devices, and then you have very different situations. And the platform is one thing, but then you also have like various application needs. So as you know, there are applications that are like more CPU intensive because they are doing a lot of computations, or they are doing a lot of relayouting and everything. Some applications are, let's say, balanced because they are using both CPU and GPU, because they are rendering a lot but also computing a lot. And there are also like GPU intensive applications where you can be using like WebGL or WebGPU, whatever. So I have some examples so that we know what I'm talking about. So for example, this is a website which has a lot of like static content. It's not changing much. There are some numbers that are changing, maybe some small graphs. But yeah, what you can expect here is that the biggest problem will be like relayouting, maybe style recalculations. Rendering is not that important here. I mean, it's a fraction of what is like to be done here. But if you take this example, for example, this is a stock chart demo. So you have some kind of waves, like charts, which are rendering. Then you have some numbers that are changing. You cannot see it because it's static, but it runs normally at 60 FPS, so it's rendering all the time. So everything is changing all the time. So in this case, the application is doing, I mean, it triggers a lot of layout and style calculations, but at the same time, it does a lot of rendering. There are multiple canvases, everything is changing all the time, the rendering is at 60 FPS. So this application is somewhat balanced, we can say, but it uses both CPU and GPU quite intensively. Then you can have applications like this. So this is a WebGL game. This is like simple arcade game. So in this case, the CPU usage won't be that big. So the game script is very simple. It's like it's just coordinating things. The heavy lifting here is on the GPU side because you have to render things. You have to apply shaders, so that's the thing. So this application, for example, it's like it needs a lot of GPU, but CPU is not that big here. So now, once you understand that there are various platforms, embedded platforms, they have various capabilities, and there are various web applications which have various needs, you may ask yourself, like, okay, what if I have application that, for example, like here, requires a lot of GPU, but my embedded platform has very, not much powerful GPU. So what happens then? So in other words, what if supply is smaller than demand? So in that case, of course, you have bottleneck, in this case on the GPU side. So basically, if your application is very GPU hungry, basically on average, the CPU usage will be very low, but the GPU will be like 100% all the time. So you have bottleneck. So what can you do about it? Well, I'll talk about what can you do with WPE WebKit and from the perspective of settings. First, what is WPE WebKit? So as previous talks explained, it's like a port of WebKit which is dedicated for embedded use cases. And what is important here is that WPE WebKit's settings by default, those are like more or less like for other browsers in terms of CPU and GPU usage. So in other words, WPE is by default configured to use as much GPU as possible, basically, because those are like typical embedded use cases anyway. So for example, Canvas 2D is accelerated, DOM rendering uses GPU, compositor uses GPU, and that's the setup. But the good news is that you can change this actually. You can tweak settings and you can change the trade-off. But the thing is that the trade-off is a keyword here because changing the CPU and GPU usage will always be a trade-off. Like if you're reducing GPU usage, you're increasing CPU usage. So you have to be aware of that. But usually that's okay. Usually there is a bottleneck on one side, so you can just change the settings and the bottleneck may be reduced or it may go away, and then the usage will be like more balanced. And you have to remember that there is no silver bullet set of settings. So there are various applications and they have various needs. So on the same embedded device, one application may require this settings and another application may require that settings to avoid bottlenecks, for example. So now I will briefly take some time and talk about the techniques, what you can do. I sorted them from like less relevant to more relevant. But then, of course, eventually the decision is up to you, up to your situation. So if you have a concrete embedded device, concrete application, then you need to ask yourself, like, what can I do and what will be working the best? So as Carlos said, we're using Skia and we're working on Skia Compositor. So soon we will be using Skia for almost everything. So it's important first to understand that Skia has a lot of small settings, like global settings, but also like, for example, we're using Ganesh right now, so Ganesh has a lot of settings as well. If we're going to switch to Graphite at some point, it has a lot of settings as well. So you can always tweak those. And here I listed just some interesting settings that you may start. I'm not going to explain them, but there are like small things that, for example, may impact like, there are some thresholds, for example, where below the threshold we're using CPU more for certain operation, or above the threshold we're using GPU more, and things like this. So that's the first technique. You can basically tweak the Skia settings and just measure what's your GPU and CPU usage, how it changes, and if it's fine for you. The second technique is about reducing tile sizes. So as Carlos said, when rendering layers, we're often using tiled backing stores. So we have those tiles, and when doing rendering, we're rendering to those tiles, we're updating them. So what you can do to reduce GPU, for example, but at the same time increase CPU usage, you can reduce the tile sizes. In that case, of course, there are more tiles, so there's more CPU usage because we need to iterate those tiles and we need to maintain those. There are more draw calls, but in general, the GPU usage will be smaller because normally with bigger tiles, on average, you will be losing like, you will be allocating textures, but some portions of textures will be unused. The smaller tiles you have, the smaller the gaps on average. Not to mention that within the tiles, when we're painting, we're not repainting all the whole tiles like each time. So if only small portion of tile changes, we are only repainting this small fraction. And this is done once per tile. So there is one repaint region per tile. So if you have more tiles, you have more of these regions. So technically you have like more granular, in this case, like dirty region tracking. So potentially you can repaint less. So that's good for GPU. So yeah, you can configure this using environment variable. So you can try yourself. Another technique is enabling damage propagation. In WP, this is disabled by default. So basically, using the runtime preferences, you can enable this. And the damage is basically information from the browser. What changed? What areas of the viewport changed during the certain frame? And the idea is that with damage propagation enabled, the browser, the WPE, the engine will send the information about the changed area along with the frame up to the platform. So for example, system compositor. So for system compositor, it's useful because it will get the whole frame, but it will get hints like what changed actually. So in some cases, if there are multiple windows are overlapping, sometimes compositor may decide even not to repaint anything because there's nothing to repaint. So this is useful, and also it potentially reduces the GPU usage. Another thing is that once we have this damage information propagated, internally within the engine, we are also hinting our internal compositor with this information. And then basically the compositor, when compositing the layers, is able to paint less, basically, because it can just clip to certain area that was actually changed. So this feature, when enabled, it reduces GPU usage. But yeah, the CPU utilization goes up slightly. Yeah. By the way, it's enabled by default on GTK port, for example. Another technique is switching the Skia backend. Yeah, we're using Skia for layers rendering, and by default we're using GPU backend. But it's very simple. You can just use environment variable to switch from the GPU backend to CPU backend. And then all the painting of the layers will be done using CPU. So it's like very simple. But at the same time, it's like it may have like severe impact on your application. So if you have a lot of layers, your application is very complex, then yeah, then it will have like it will have impact. It won't affect Canvas 2D, for example, but that's another story. Anyway, this is simple and yeah, worth trying sometimes. Then another technique is regarding the Canvas 2D. Normally in WP, we are accelerating Canvas 2D, usually depending on the size, but bigger canvases are accelerated. So with the runtime preference, you can disable the Canvas 2D acceleration. So in that case, it will be like all the way CPU. So this is also a simple setting, but if you're using Canvas a lot, it may significantly change the situation. So if you need to reduce GPU, you'll use a lot of Canvas, just disable this, and yeah, the CPU will go up. But yeah, maybe that will work for you. Yet another technique, but this is like a big one actually, is disabling compositor, the internal WP's compositor. So right now I'm talking about the texture mapper, so the old one, which is going to be replaced by the Skia compositor. But anyway, when you're using compositor, it's GPU bounded. It's texture mapper, for example, uses OpenGL, and you cannot really change it. So what if you don't want compositor to use OpenGL? Well, you can disable it. And we have runtime preference for that. In WP, it's experimental. It's not properly tested, but it's worth trying if you really need to. So what does it mean to disable compositor? Basically, normally the browser, it takes some layers and basically bugs them using textures, so that if certain layers are not changing often, you can just composite them without doing anything. You just have texture, you have texture that is already painted, and you can just composite it multiple times on various occasions. If you disable compositor, those layers will not anymore be bugged by anything. Basically, the compositor tree will be like flattened, and basically any web content, any content that's supposed to be on the layer, will be drawn directly to the frame. So it's very expensive in terms of like CPU, but of course, without compositor, you won't be using GPU anymore. So this is a significant change. You have to be careful with that. But if, for example, if your device doesn't have GPU at all, you're just using frame buffer, yeah, this setting may be like very interesting. Although, as I said, it's experimental. Not sure if we will be working on this. It depends on the interest, actually. Then, of course, there are other techniques. There are small tweaks that you can do with environment variables, but there are many small things you can do. You just have to figure out on your own, because usually it very much depends on the use case. And of course, there are like big changes outside our browser. You can use libgl software to change, Mesa backend for a certain application, but this is something like last resort techniques, basically. So what about the future? As you know, what Carlos was saying, we're moving from texture mapper to Skia-based compositor within WebKit, and actually it has quite big consequences, because texture mapper is bound to OpenGL. Like, you cannot do anything about it. But once we have Skia compositor, then technically, with some amount of work, technically you would be able to switch compositor within WebKit, within WP WebKit, to Skia CPU backend, for example. Also, if it would be using, for example, Skia GPU with Ganesh, so with OpenGL, technically, as Carlos said, you can switch to Skia GPU with Graphite, so with Vulkan. So you will be able to switch between backends, and this may be really interesting because it will offer like a lot of flexibility, which will be great. And yeah, that's it. Thanks. Do you have any questions?
Thank you, Paweł. Yeah. Any questions here remote? Yeah, there's one question. Actually, you have the microphone there, I think. Is it working?
Yeah. Do you have any timeline when you would like, or when you would officially support Vulkan backend with Skia rendering? When it will be available? Like more stable?
We don't have timeline, but in general, the first milestone is to have Skia compositor, as Carlos said. Once this is ready, we'll probably think about it. We'll probably start with experimenting, and I think it depends on the performance. So for example, if we have Skia compositor ready, let's say end of this year, I don't know, And if we do some like quick experiment, switch to Vulkan, and it turns out that, for example, for our customers, the improvement is like significant, then probably it will be prioritized and we will do it quickly. But if the performance gains will not be that big, probably it will be like, you know, we will get there, but it won't be like priority. So I would say it depends on how much we're going to gain.
I mean, on some proprietary drivers, it doesn't have to be, it is also about performance, but sometimes also about less bugs on the driver level with Vulkan implementations. So sometimes you can be hitting some bugs with GLES which are not present on Vulkan.
Yeah, it's true.
It needs to be tested case per case, yeah.
Yeah, we'll be testing. We'll see. We'll see how it goes.
Okay, any more questions? We still have a few minutes, so don't be shy. Trick question.
Yeah, it's actually about the question that that they were doing. What is your feeling about then, or anyone in the room, about the quality of the Vulkan and OpenGL APIs in proprietary drivers? We are really interested in the feedback from people that are like testing multiple embedded devices with proprietary drivers to verify, like, do you feel that Vulkan is better for those cases?
Please speak to the microphone.
I think our team is reporting more bugs to GLES backends than Vulkan backends, for example, to Qualcomm.
For any specific driver, or well, the one that you're using, which is proprietary, I guess, no?
Yes.
Okay.
Yeah, and we have a lot of bug reports related to GLES, but our graphic team is saying that Vulkan is much stable. I don't know details exactly, but things should work better there. Especially with the Skia, I mean, with fences and stuff, with also with EGL. EGL is a little bit problematic. The display pipeline of the EGL, the distractions, yeah, there are some issues which are not present on Vulkan.
Okay, any more questions?
Any more questions from here or online? Okay, so since there are no more questions, I think we can stop it here, Paweł. Thank you.
Thank you.